Hello class, welcome to the last lecture. In this lecture, I would like to review some important formulas in the course. The first one for risk return and the historical record, you should to remember the important formulas for the arithmetic average of annual returns. I bar is equal to the sum of the real returns divided by the numbers of the observation. Here we have the annual real return and divided by n. For the geometric average of annual returns, this is equal the product of the raw return and raised to the power 1 over n minus 1. For the continuous compounding rate of return, RCC equal to the logarithm of 1 plus the effective annual rate, EAR. For the expected return, this is the summary. This is the sum of the probability of the scenario I multiplied by the return in that scenario. For the variance, this is the sum of the probability of the scenario I multiplied by the deviation from mean in the scenario square. For the Sharpe ratio SR, we have equal the portfolio risk premium divided by the standard deviation of exact return, and RP minus RF divided by the sigma P. For the real rate, small r, the nominal rate, the capital R, and the inflation I, we have the real rate equal 1 plus the nominal rate divided by 1 plus the inflation rate and minus 1. For the real rate continuous compounding equal the nominal rate R minus the inflation rate I. For capital allocation to risky assets, the utility score yield equal the expected return minus 1 over 2 multiplied by A is the risk aversion, and multiplied by the variance sigma square. For the expected return on complete portfolio, this expected return of the combined portfolio equal Y multiplied by the portfolio P and plus 1 minus I Y multiplied by RF. For the standard deviation of complete portfolio, we have the sigma C equal Y multiplied by the sigma P. For the optimal allocation to risky portfolio, we have the Y star equal the RP minus RF and divided by R multiplied by the sigma P square. For the index model, we have a single index model, RIT equal alpha E plus beta. For the single index model, we have RIT equal alpha I plus beta I RMT plus EIT. This is the error of the model. For the security risk in index model, we have the sigma I square equal beta I square multiplied by the sigma M square and plus the sigma of the error square. For the covariance of the I and R chase, we have the beta I multiplied by the beta chase multiplied by the sigma M square. For the CABM model, we have the beta is the covariance RI and RM divided by the sigma M square. And for the security market line, we have RI equal RF plus beta I RM minus RF. For the efficient market hypothesis, we need to understand the abnormal return equal the actual return minus the expected return given the return on the market index. For the bond prices and yield, we have to remember the formula to value a coupon bond. This is the discounting of the coupon, and this is discounting of the face value. Because the coupons is equally likely, and so that we can use the annuity formula here. For the equity valuation models, we have the general formula to value to determine the intrinsic value. That means the P0 equal to discounting all of the dividend in different period to 0. And for the constant rule model, we have the P0 equal the dividend of in the period 1 divided by K minus G. For the row opportunity, we have the formula P0 equal E1, this is the earning in the period 1, divided by K plus PBGO. For determining P ratio, you need to remember P0 divided by E1 equal 1 divided by K and multiply by 1 plus PBGO divided by E1 divided by K. For the free cash flow to the firm, you need to remember the FCFF equal EBIT multiplied by 1 minus TC, here is the corporate tax, plus depreciation minus capital expenditures and minus increases in net working capital. For the free cash flow to equity or FCFE equal FCFF minus interest expense multiplied by 1 minus tax plus increases in net debt. This is all of the review of the course. Thank you for listening. Goodbye.